So with quadratics today, we're talking about quadratic functions or polynomial functions where the highest power of x is 2. So it's a polynomial with a degree 2 polynomial. It's always going to be in the form ax squared plus bx plus c. These are things we know. A cannot equal 0. A, b, and c are elements of real numbers. That's a quadratic function. And then the graph of a quadratic function is called a parabola. Those are things we've known before. A quadratic function is going to have a maximum or a minimum point on the graph. Okay. And does anyone remember what that maximum or minimum is called? What's that point called at the end of the graph? The vertex. Good job, Hannah. All right. So yeah, that's the vertex. Okay. And then, okay, so that's true for our quadratic functions. Okay. The x-intercepts of a graph are the points where the graph y equals f of x cuts the x-axis. So it's just where it crosses the x-axis. All right. These are also called the zeros of the function. So if you hear me using that word zeros, that's what the x-intercepts are. All right. And that's basically where we're saying, hey, when the y value equals 0, what's the x value going to be? That's what the zeros of the function are. So what are the x values at the x-intercepts? That's what the zeros are. Okay. We can find the zeros using the quadratic formula. We can find them by factoring. Okay. So we can find zeros by factoring. We can also plug in 0 for x or 0 for y. All right. And then the last thing is we can use the quadratic formula for finding zeros. And the quadratic formula, if we remember correctly, is negative b plus or minus the square root of b squared minus 4ac all over 2a. That's another way to find the zeros for this type of function. And I don't remember, hopefully you guys have the quadratic formula memorized. I don't remember if it's on the test or not. Let me grab my formula sheet. So the quadratic formula does not look like it's given to you on the IB exam. So that's one, if you're taking the IB exam, you gotta have that quadratic formula memorized. All right. Or if you don't know how to use the quadratic formula, you don't want to memorize it, you gotta be resourceful. How do I find the zeros on my calculator? Okay. So you gotta know how to do those types of things. Y-intercept occurs when you plug in 0 for x. That's the next part. All right, 3 forms of a quadratic function. Each form tells us something about the function. Do you guys remember what what's one of the 3 forms of quadratic function?
It's the, wait, is that like the upward, the downward, and then the sideways?
No, it's 3 ways to write the equation. 3 forms.
Vertex form?
Vertex form is one of them, yes. So vertex form.
And is point slope? No, that's a different one.
Point slopes for linear functions.
And they're standard, I know that.
They're standard form, yes. So let's start with vertex form. We're going to say y equals a times x minus h squared plus k. All right. And vertex form tells us the vertex.
And there's factored form as well.
Yes. It's the vertex h comma k. Next one is standard form, which we already mentioned. A y equals ax squared plus bx plus c. Anyone remember what standard form tells us? It tells us the c value. The c value is important. The c value is the y-intercept. If I plugged in 0 for x, I'm going to have the plus c left over. So the y-intercept is the c value. That's standard form. And then the last form is factored form. We might also know it as intercept form, another one we could have called it. X minus P, X minus Q. Tells us the zeros. P and Q would be the zeros. Okay, those are the three forms: vertex form, standard form, and factored form slash intercept form tells us the zeros. Okay, vertex form tells us the vertex, the location of the vertex, and standard form tells us the y-intercept. All right. One big problem IB loves to put on their tests is the line of symmetry, which we also call the axis of symmetry. So if you're planning on taking the IB exam, axis of symmetry, that's a huge one. Okay. How can you find the axis of symmetry with each of these three forms? Okay. With vertex form, the axis of symmetry is x equals h. So that's kind of nice. It's the x value of the vertex. And we always, always, always write the axis of symmetry as an equation. Okay? Always written as x equals. All right. Standard form. And you remember how to find the axis of symmetry from standard form? So let's see. For those of you that have had me as a teacher before, maybe in AGS2 way back freshman year, shout out to way back then. We had a little jingle to find the axis of symmetry in standard form. Do you remember the jingle? We're getting to that holiday season. It's time for jingles, guys.
Pop Goes the Weasel.
Pop Goes the Weasel's for the quadratic formula. My jingle's way better than Pop Goes the Weasel. All right, who had me in AGS2 freshman year? Hannah, Drew, shout out to you guys. Do you remember the jingle?
I have no clue.
No clue. Colton, you were there freshman year too, weren't you? Cole? No?
Yeah, it was.
Yeah, do you remember the jingle?
Which one?
Oh, for the axis of symmetry for standard form quadratic. Oh.
Probably do, but I don't want to get it wrong and then sound dumb.
Oh my gosh. Oh my gosh. I don't want to sound dumb. Come on. Get out of here. You're not going to sound dumb for taking a risk. Come on. All right. So the jingle for standard form quadratic goes like this. Negative b over 2a. That's it. That's our jingle. I love it. So easy. So, negative b over 2a. So
What
simple.
song is that?
What'd you say?
What song is that?
That's a street special. That is just a, yeah. Patent pending. I don't know if we can put a patent on a song, but, you know, we're working on it. No, actually, I stole it from Mr. Ford. It was Mr. Ford's song originally. But, yeah. He let me steal it from him. So I can't say it's a street special. But hopefully you guys from AGS2 remember the jingle. Gosh. A little disappointed in you. Yeah.
Sounds like Zippity Doo Dah.
Zippity-doo-dah. Yeah, that's true. That could work. All right, and the last one, factored form. To find these axis of symmetry in factored form, you're going to add your x-intercepts together and divide by 2. And your textbook does show you this one in factored form, how to do add the x-intercepts together and divide by 2. But you should be able to find the axis of symmetry for any form that you're in. You got to be able to identify the axis of symmetry, which is that equation for x. Okay?
So for the for vertex, it's the x value of the vertex, and then for factored form, it's the zeros over 2. Then what's like the thing for standard?
So I'm going to write it down now. Add the x-intercepts. And divide by 2. And what's the thing for standard form? It's the jingle. Standard form is just the jingle. That one's just like a, hey, here's a fun fact. There's a way to prove it algebraically. I'm not going to show you that method. So
I mean, you have like the x value of the vertex, add the x-intercepts, and divide by 2. What's like the description for that one?
Yeah, I know what you're saying. The description for standard form is the jingle. There's no good description for standard form, unfortunately. Yeah, like basically what your textbook says to do to find the axis of symmetry is rewrite it in factored form and then add the intercepts and divide by 2. That's how your textbook talks about it. But if we know the jingle, we don't need to do that. We can skip a few steps and just do it from standard form. So that's the idea for the 3 ways to find the axis of symmetry. Okay, I have one example today that I want to look at. It's example 4 from your textbook in chapter 9. And it's a rectangle problem. It says a rectangular mirror has a perimeter of 260 centimeters. The length of the mirror is x centimeters. So that means like this is x centimeters length. Find the height of the mirror in terms of x. So that's part A, find the height. So think about 2x plus 2y is going to equal 260 centimeters, right? The y value is going to be like our height. Okay. And now what we can do is we can say, okay, well, there's going to be 2x plus 2y is our perimeter. If I divide everything by 2, I can simplify this a little bit and say, well, x plus y is going to equal 130. And then I'm just going to write this as an equation, y equals. So I'm going to subtract x from both sides. I'm just going to put this in terms of the height. Y equals 130 minus x. That's going to be like our, that's going to be solving for y, basically solving for your height, which we don't know what it is yet because we don't have an x, but it doesn't matter what x is, this is how you'd find the y value once I give you an x value.
When it says in terms of x, what the heck does that mean?
It means set up an equation so that way whenever you plug in whatever value you want for x, you can solve for y as well. So if I said, hey, it turns out the length of the mirror is 7 centimeters, how long is the height? So that you do 130 minus 7, you'd say, oh, the height's 123. Or it turns out the length is 47 centimeters. Now you do 130 minus 47, you'll find the height. That's what it means in terms of x, okay? Part B, I'm going to zoom in a little bit because we were zoomed way out. It says find an equation for the area of the mirror also in terms of x. So this is where the quadratics is going to come in. Area is length times width. So the length is going to be x. The width is going to be 130 minus x because we want to put it all in terms of x again. And now I can go ahead and distribute that and say area equals 130x minus x squared. And because I'm a snob, I'm going to rewrite it in standard form. Negative x squared plus 130x. That's my area. You could leave it written like this. That's perfectly fine. I like to rewrite it in standard form, quadratics. Okay. And now the rest of the problem is going to ask us to interpret data about this type of problem. So we use the perimeter to solve for whatever the height is. Okay, that was the point of the perimeter equation. And then we're able to write a quadratic function now. And it's in standard form quadratic. And then this would have been factored form quadratic right here. So technically we have a quadratic in factored form, x times 130 minus x. We have a function in standard form, x negative x squared plus 130x. All right, plot the graph of your equation for the area of the mirror, showing A on the y-axis and length x on the x-axis. Choose a suitable domain and range. Okay, so if I were to graph this now, and I have to pick a domain and range for what's going to work for this problem. All right, we got it? Good. Get out of here. So now, for this problem, I can graph like x times 130 minus x, something like that. I could graph negative x squared plus 130x, and I should get the exact same equation. First thing you'll notice is it looks really weird because it says pick a suitable range. So if I zoom out, hey, there we go. That looks a lot better. So that's why it says domain and range suitable. So let's take a look real quick. It goes all the way up, the y value goes all the way up to 4,225. So on my settings, I probably want to go from, let's say it goes from 0 on the y, and it goes back to 0 there. So x goes to 130, it looks like. So let's go for x's. We'll go from negative 10 to 140 or something like that. And then on the y's, it goes from probably like negative 10 to, I don't know, like 4,500. So a little higher than that. Maybe it'll go down a little bit, but now I can see a decent quadratic function. All right, that's what it means by pick a reasonable domain or range. And the way I picked my domain and range, honestly, was I graphed it first. And what I did is I just zoomed out and said, okay, how am I going to make this look like a parabola? And then I just determined, hey, there's my maximum value, 4,225. I see my x-intercepts at 0, 0, and 130, 0. And now I can build my domain and range around that. So like domains, for example, probably 0 to 130 is a reasonable domain. Range from 0 to 4,225 would be a suitable range. Okay. So that's what you'd say for your domain and range.
So I'm trying to graph it on my calculator, and it's being really weird and saying error invalid dimension. But I like just put it in like the y equals button.
Did you
And I
put, so you did standard form negative x squared plus 130x? You
Mhm.
probably used the minus button instead of the negative button, and that's why your calculator's not working. So if you put the negative x button instead of the minus button, it should work.
I did it again, and it said that underneath it says check one dim list less than.
Oh, I know what the other problem could be, is you might have stat plot on since we just finished statistics. So on
Okay,
your
how do I do
y
that?
equals, when you're on the y equals screen, if you have any plot 1, plot 2, plot 3, if any of them are highlighted in black, you have to unhighlight them in black, and then you can graph it. Okay, since we just finished our statistics unit, that's a possibility.
It was exactly that.
Okay,
Thank you.
yeah, you're welcome. Oh, 4,225, that's what I want to say. That'd be our good estimate for the range here. Okay, I'm going to switch back to my iPad then. But we're going to use this graph the rest of the problem and kind of identify information. And that's really what the IB exam expects of us, is to be able to graph these functions on our calculator and use our calculator to identify things. So it says find the coordinates of the points where the graph intercepts the x-axis. If I'm using a calculator, I'm going to find the zeros on my calculator. All right. And in this case, there's 0, 0 and 130, 0. The other way I find the zeros is in factored form, I have the x times 130 minus x, and I set the whole equation equal to 0, and I write it down as, well, x equals 0, and 130 minus x equals 0. And then I would get x equals 130. So that would be where my zeros come from. All right, algebraically, I can prove it too. Okay. Next part, state
Move
what,
to the right a little bit.
sorry, what'd you say?
Can you move to the right a little bit?
No,
Okay.
there you go. So then the next part says state what these two values represent. So now we're looking at the real world context of the problem, and the two values of x represent. So your two zeros, right? So the first value is saying we have a length of 0 centimeters. And then the 130 would be we have a length of 130 centimeters. But if you have a length of 0 centimeters, then your height is going to be 130. If you have a height or a length of 130 centimeters, your height's going to be 0. So that's why your area, total area of the mirror would be 0, because you don't have any height or you don't have any length respectively for those two particular problems. So that's what the state what these two values represents means. Okay. So you either have length of 0 or height of 0. Okay, that's the idea there. And then hence find the equation of the graph's line of symmetry or axis of symmetry. So in this case, if I'm in factored form of this equation, I know my x-intercepts are 0 and 130, so I say 0 plus 130 divided by 2. And I would get 65, or I'm sorry, I'd get 130 divided by 2, which is 65. So the axis of symmetry is 65, which makes sense because that is on the vertex. That's the x value of the vertex. Okay. But when it says find, IB exam expects you to show your work. So important that we show our work with one of those methods. If we were in standard form, we could have done the negative b over 2a. In this case, it would have been negative 130 divided by 2 times negative 1. So it would have still been that positive 65. All right. State what the equation of the line of symmetry tells you in this context. All right. And in this case, think about it. It's a maximum. And we're maximizing the area of this problem. That's what the y values are. So if x equals 65, then I'm going to have a perfectly square mirror that's 65 by 65. And that's going to give me the largest possible area for my mirror. All right, so that's what the equation of the axis of symmetry is. It is saying my mirror is 65 centimeters in length.
Wait, that's the max value?
Yeah. So on the graph, if I was looking at the graph, when I put in 65 for x, I'm going to get the maximum possible value. Okay. This gives me the max possible volume.
Possible volume or
It's getting, so the x value is my length. The y value on this graph was giving me, not volume, area, sorry. Max possible area, not volume. Thank you. So the max possible area of the mirror, not volume. Okay. If it was 3 dimensions, it would be a volume, but in this case, it's 2 dimensions, it's area. All right. That's what problem example 4 looks like. For your assignment tonight, I'm just asking you to do exercise 9A, problems 1 and 2. For problem 2, you'll need to do parts A and B. I didn't like the wording on the second half of it. For 9B, do problems 1 and 2. For 9C, do problems 4 and 5. And again, it's just practicing these types of problems. For example, exercise 9A just says, plot the graph, and then you're going to do a quick sketch of the graph. You're going to mark the coordinates of the vertex and the points where the graph intercepts the axes. So the x and y intercepts and that's all you need to do for problem 1. And state the domain and range of each function. So if you need help stating domain and range, we can definitely do a problem like that. And then problem 2, it says consider the graph given by this equation. Find the coordinates where the graph crosses the x-axis and find the coordinates of the x-intercept. So again, just having you practice on your calculator. That's what exercise 9A is doing. Exercise 9B literally just gives you standard form equations. It says identify the A, B, and C values. All right. Exercise 9C, I give you some real world problems, and I'm just asking you some questions about them. That's what exercise 9C, problems 4 and 5 are asking. So I think it's a pretty quick assignment for you guys. Remember, this is semester 2 now, so this is going to be the first assignment that goes on your semester 2 grade. Remember, everything's starting fresh. Doesn't matter where you were before. So make sure you guys start semester 2 on a strong note. Get your homework turned in.